Okay, so I want to finish up our discussion of Gauss's method for finding sums of arithmetic sequences by giving you two, maybe three examples. I'll see how much time these things are taking, but we've looked at sums that start at 1 and end at some number. We'll say like 108. 109, 110, right? So we've looked at sums like this. So I'm not going to give you any more examples of those. You can see some of my previous videos about that, Gauss's method to find that sum. Okay, so I'm not going to work that one out. We've also looked at sums that don't start at 1, but that still increase by increments of 1. So, we've looked at sums like 11 plus 12 plus 13, and then end at some number, right? 197, 198, 199. So we've looked at these kinds of sums as well. So, and I actually, in the previous video, I gave you two different ways to kind of think about this one. Two different ways that you could possibly approach that one. One of the ways was to just use Gauss's method the way you normally would, right? Add this list to itself backwards and then add them up, and then count up how many numbers are in the original sequence, right? And then the other way was to fill in the part that's missing, fill in the first 10 numbers, find the sum of all of the numbers from 1 to 199, and then subtract off the sum from 1 to 10, right? So that was the second way that we talked about doing it. So what I want to do now is talk about finding sums like this, right? So 5 plus 10 plus 15, where we're not increasing in increments of 1 anymore. So maybe we go up to 105, 110, and then 115. Okay. So let's see if we can figure out what this sum is. So if I sort of go with my gut instinct and use Gauss's method like I normally would, then I would just add this list to itself backwards. And let me do this in red. When I do that, I get 5 plus 115 is 120, 10 plus 110 is 120, 15 plus 105 is 120. So it seems to work out still, right? So Gauss's method still works for this. Whoops, 120 and 120. Alright, so Gauss's method is still working out because we're still getting the same number when we add those two lists together. The question is, how many times are we adding 120 to itself? Well, we're adding 120 to itself however many times there are numbers on the list, right? So we've got to know how many numbers are on this list. To figure out how many numbers are on the list, maybe I'll do a little bit of scratch work up here, and I'll say, well, I'm increasing by 5, and moreover, I'm starting at 5. So that means all of the numbers on this list should be divisible by 5. And if I take out a 5, then the list that I'm left with is 1 plus 2 plus 3 and so forth, all the way up to 105 divided by 5 would be what? 21? 21, 22, and 23. Okay? So when I rewrite it this way, it's very clear that there are 23 numbers on the list. So how many times am I adding 120 to itself? I'm adding it to itself 23 times. Okay? And so that tells me that the original sum, right, 5 plus 10 plus 15, all the way up to 115, is 120 added to itself 23 times. Okay? But that's twice the sum that I was looking for, right? Because I doubled the sum in order to get the 120s. So I need to undo that doubling by dividing by 2. Okay? So that's one way that you could do this problem. If I'm going to just work that out on my calculator. 120 times 23 divided by 2 is 1380. So 1,380. Okay. As always, I want to give you multiple ways to think about this, though. So here's another way that you could think about this. You could think about this by using what we did up here to find the number of numbers on the list. Notice that if you factor out a 5, this just becomes the sum from 1 to 23. And what if we just use Gauss's method on that, right? And then multiply that sum by 5. Right? We should get the same thing. In other words, if we find the sum from 1 to 23, and then we multiply that sum by 5, we should get the same answer as if we were finding this sum that we initially started with. Okay? Well, so let's do that, right? The advantage to doing it that way is that it's easy to tell how many numbers are on the list when it's written in this format. So anyway, so if we use Gauss's method here, we're going to do 23 plus 22 plus 21 plus 3 plus 2 plus 1. And if we add these things up, we get 24 plus 24 plus 24. And how many times are we adding 24 to itself? Well, it would be 23 times. There are obviously 23 numbers on this list. Okay. So the original sum, 5 plus 10 plus 15, all the way up to 115, it should be 24 added to itself 23 times, okay, divided by 2, because that doubles the sum. But then we need to multiply that by 5, right? Because of this 5 out here that we factored out at the beginning. So it has to come down, and we have to multiply by 5. You could write it maybe like this or something. So let's see if that works out. I'm going to do 5 times 24 times 23 divided by 2. Sure enough, 1,380. Okay. Very good. So, so two ways to kind of think about that one. So now, let's take it a step further. Let's do something like this. So let's do 35 plus 40 plus 45 and so forth. And let's end this one at, I don't know, maybe 240 plus 245 plus 250. So we'll end at 250. Let's see if we can figure out this sum. Okay. So I'm going to use Gauss's method. So I'm going to add the list to itself backwards. And then we cross our fingers and hope that we get the same number each time. So when I add 35 plus 250, I get 285. When I add 40 plus 245, I get 285. So it seems like it's going to work out, right? So we're just getting 285 added to itself a bunch of times. How many times? How many times are we adding 285 to itself? Well, in order to figure that out, I think I'm going to have to, so I noticed that the first number is divisible by 5, and then I'm moving up by 5 each time. So, I'm going to factor out of 5. And if I do that, what am I left with? 7, 8, 9. So 7 plus 8 plus 9. 5 into 24, or 240. Well, 5 goes into 24 4 times with 4 left over. So it must be 28, I think. 29, yeah, 30. Is that right? 5 times 30? Oh, no, that's not right. 240 divided by 5. It's 48, not 20. Oh, I said 4 times and then I wrote down 2, didn't I? Anyway, 48, 49, 50. Okay, my apologies. Okay, 48, 49, 50. Okay, so I know that there's not 50 numbers on the list though, because this list doesn't start at 1, it starts at 7. So I'm missing the first 6 numbers. So there's really 50 minus 6 numbers on the list, right? So it's 50 minus 6 equals 44 times. So I'm really adding 285 to itself 44 times. Okay, so then the sum is going to be, so the sum 35 plus 40 plus 45 all the way up to 250 is going to be 285 added to itself 44 times, but that's double, so I need to undo the doubling by dividing by 2. And let's see what we get. 285 times 44 divided by 2 is 6,270. Okay, so that's one way that you could approach this. But now, this thing that we wrote out over here gives us another way we could potentially think about approaching this, right? We could say, okay, well, what if I just try to find this sum and then multiply it by 5, right? So I could do Gauss's method on this thing. So if I add these up, I'm going to get 57. 8 plus 49 is 57. That one took me a little while, but pretty sure I'm going to get 57 each time. And how many times am I adding this to itself? Well, same trick as before, right? The list ends at 50, but it didn't start at 1, right? I'm missing the first 6 numbers on the list, so it's 50 minus 6 equals 44 times. Okay, so then my sum this time, 35 plus 40 plus 45 all the way up to 250 is going to be, well, first of all, I've got to bring the 5 kind of along for the ride, right? I'm going to multiply 5 times, and then it's going to be 57 added to itself 44 times divided by 2. Okay, so let's see if we still get 6270. Yep. So 6270. Okay, and then I want to give you one more way that you could think about this. So when we were talking about doing these kinds of sums, the ones that didn't start at 1 but that started, somewhere else, we said one of the ways that you could do it would be to find the entire sum. So to put the numbers that you're missing, find the sum from 1 to wherever you end, and then subtract off the sum from 1 to wherever you begin. right? And that'll leave you with the sum that you're trying to find. So let's see if we employ that strategy. If we employ that strategy to this particular list, I think we're going to get two different ways to kind of think about it if we approach it in that way, right? So, so if we were trying to start this sum where it's supposed to start, right? So you're increasing in increments of 5, so it should start at 5, really, right? So if I add 5, 10, 15, oh, I guess I could just do the whole thing. 15, 20, 25, 30, and then the original list, right? 35, 40, 45, and then I'm just going to cut to the chase and put, 250 here. Okay, so the sum that I'm actually interested in is the stuff in black. But what I can do is find the entire sum from 5 to 250 and then subtract off the sum from 5 to 30. Okay, so that's what I'm going to try to do. Okay, so I'm going to do this using Gauss's method, which means I need to add this sum to itself backwards. So I'm going to do 250, 245, 240, right, and so forth. Maybe here, well, I don't know where I would be actually. I'd have to think about it. But here I'm going to end up back at 5. Okay, so when I add this to itself, I'm going to get 255 plus 255 a bunch of times, right? So how many times? How many times am I adding 255 to itself? Well, in order to figure that out, it might be good for me to factor out the 5 like I've been doing, right? Like I did up here. So if I factor out the 5, what am I left with? I'm left with 1 plus 2 plus 3 plus 4, right? Plus 5 plus 6, and then the original sum takes over, right? Plus 7 plus 8 plus 9, all the way up to whatever 250 divided by 5 is. So 5 goes into 25 5 times, right? So all the way up to 50. Okay. So here I can clearly see that there are 50 numbers on the list. And here there were 50 numbers on the list, so I was adding this to itself, so I was adding 255 to itself 50 times. Okay, 50 times. So it's 50 times. And I'm almost running out of space, so I'm going to add another sheet of paper so I can just continue this on. This way. Okay, so so I know that the entire sum of the green plus the black is going to be 255 times 50 divided by 2. Okay, but I'm only interested in knowing what the sum of the black terms are, so I need to subtract off the green terms here, right? So I need to subtract those off. So so let's figure out what that sum is, right? So for the green part, 5 plus 10 plus 15 plus 20 plus 25 plus 30. There's not very many numbers on that list. You could probably just punch that into your calculator and get a pretty quick answer, but let's use Gauss's method for it anyway. 30, 25, 20, 15, 10, and 5. And then if we add this up, it's 35, 35, 35, and it's 6 times, right? 1, 2, 3, 4, 5, 6 times. 6 times. You could also see that it's 6 times because up here you had 6 numbers in that green list. It's pretty clear that it's 6 numbers, right? Okay, but it's 6 times. All right, so this is 6 times. Okay, so finally, to get our answer, we can say this. We can say 35 plus 40 plus 45 all the way up to 250 equals, well, it's the entire sum from 5 all the way up to 250, which we said was 255 times 50 divided by 2 minus, or maybe I should do the minus in green, but minus the sum of the green stuff, which is 35 times 6 divided by 2. Okay, let's see if we get the same answer as what we got before. So before we were getting 6,270. Let's see if we still get 6,270. 255 times 50 divided by 2 is 6,375. $35 times 6 divided by 2 is 105. And then we subtract 6,375 minus 105 and get 6,270, sure enough. Okay, so there's that second approach. It's kind of hard for you to see the whole thing on one screen. There you go. My dot cam isn't very high tech. The only way I can zoom out is to kind of do this, hold my dot cam up so you can see the whole thing. Okay, but there's that approach, and we end up with the same answer as what we got before. So then finally, the last approach is very similar to this third one that we took, right? So the last approach, for the last approach, we're going to say, well, we want to find the sum from 1 to 50. Using Gauss's method, that's going to be okay, we'll say plus 1. So when we add this to itself, we get 51 plus 51 plus 51. So we're just getting 51 a bunch of times. How many times are we adding 51 to itself? Well, it's pretty clear because we did the factoring that there are 50 numbers on the list. So it's going to be 50 times. Okay. We need to subtract off the green part though, right? So how do we subtract off the green part? Well, let's figure out 1 plus 2 plus 3 plus 4 plus 5 plus 6. 6, 5, 4, 3, 2, 1. You add them up, you get 7, 7, 7, 7, 7, 7. And you're getting that 6 times, right? So our original sum, 35 plus 40 all the way up to 250 is going to be the original sum from one, not the original sum, sorry, the entire sum from 1 to 50, right? That was 51 added to itself 50 times. That's doubled, so we divide it by 2. And remember, we factored out a 5, so we've got to bring that 5 along for the ride and say it's 5 times, 51 times 50 divided by 2, minus the sum of the green stuff. Now the green stuff is going to be 7 times 6 divided by 2, but again, right, the 5 has to come along for the ride, so it's 5 times 7 times 6 divided by 2. And then to verify that this is the same sum as what we've been getting, notice that 5 times 7 is 35, okay? And 5 times 51 is, well, 5 times 5 is 25, and 5 times 1 is 5. 25 plus 5 is 255, right? So 5 times 51 is 255. So sure enough, these are going to be the same thing, right? You're going to get 6375 for the black part and 105 for the green part, and that's going to leave you with 6270 at the end of the day. This particular format is the most deconstructed of all of the formats, right? Whatever deconstructed means. But I mean, it's the most broken down of all of them. That doesn't make it better or worse, but it's just a different way of thinking about the same thing. So there you go. So for that particular sum, 35 plus 40 plus 45 all the way up to 250, I've given you 4 ways, right? 4 ways that you can kind of think about that one. So I think that's all I want to say. I'll give you a little teaser of something that may or may not be an extra credit problem, and so on a test. And so it would be a good thing for you to think about this one. So if you watch to the end of the video, then you'll be rewarded by having what I think will be an extra credit question on test 2. It might not be this exact question, but it'll be something like this question. So the sum that we just did, right, 35 plus 40 plus 45 and so forth, right, this thing, all of these terms were divisible by 5. So we could factor out a 5, and that was very useful because it helped us to find the number of terms in the sequence. But what if it didn't, what if the number of terms did not, or what if the terms were not divisible by 5, but you were nevertheless going up by 5s? Or what if they weren't all divisible by 3, but you were going up by 3s? Like, what if you wanted to find, say, this sum, right? 22 is not divisible by 3, but if you wanted to find 22 plus 25, right, so if you add 3 each time, plus 28 plus 31, and then where would we end? Maybe 106 plus 109 plus 112. Okay. Now, if you're asking yourself, how did I know to leap from 31? Like, how did I know that 106 would be like on this particular series? Well, it's because I know that 105 is divisible by 3, because the sum of the digits of 105, 1 plus 0 plus 5, is 6, and 6 is divisible by 3, and that means that 105 is divisible by 3. So this is just a divisibility rule that I have memorized. Anyway, so 105 is divisible by 3, and so is 21. 22 is just 1 more than 21, right? And 106 is just 1 more than 105. So I knew that 106 would be an appropriate number that would fall on this list. Anyway, so if you wanted to find this sum, this is a little trickier, right? Notice that you can still use Gauss's method. If you add 112 plus 109 plus 106 plus 28 plus 25 plus 22, you get the same number each time, right? When you add this to itself, you're still going to get 134, and here you're going to get 5 plus 9 is 4, carry the 1, you get a 3, and then a 134, sure enough, right? 6 plus 8 is 14, carry the 1, it's a 3, 134, right? So you're going to get 134 added to itself a bunch of times. The question is, how many times? Right? How many times are you adding 134 to itself? And like I said, this is a little trickier because these numbers are, you're going up by 3, right? You're going up by 3, but none of the numbers are divisible by 3. So you can't just factor out a 3 to figure out how many numbers are in the list. So since this is potentially an extra credit question, I don't want to give you the answer. I want you to think about this. and think about how you could find the number of numbers on that list without actually having to write them all out and count them up, right? So on a test, just to make sure that you're not going to do that, I might go all the way to like 1,000 or something, so that you don't just sit there and like write out all the numbers and add them up. But the hint would be something that I said a second ago, that like 22 is not divisible by 3, but 21 is. Okay, so maybe you could like fix up all the numbers in some way, so that the numbers are divisible by 3, and just remember that it doesn't matter what the numbers actually are, as long as there's an equal number of numbers on whatever list you're using to decide how many numbers are on the list. So that's kind of vague and ambiguous, I guess, but it should be if this is extra credit, right? So that's all I have to say about that. And that'll conclude our discussion of Gauss's method.